$35,000. 3 continents, 1 drone design, fired in more wars than any other. The treaty meant to govern it was written to expire on a fixed date. When the date arrived, the weapon kept selling, now legally. In 2026, that same design was fired back at the country that built it. When a weapon outlives its treaty, who governs it?
Let's get into it.
In 2011, an American stealth drone came down almost intact on Iranian soil. Within 3 years, its descendants were rolling off a production line. This is the Hamberger report. I'm Andreas Hamberger, enterprise architect, Wellington. The captured aircraft was a $6 million machine, built to fly deep, see everything, and come home. What it gave the country that recovered it was not stealth. The copies were never as good as the original. What it gave them was something cheaper and more dangerous. The shape of a flying wing that could be built by the 100 and never needed to come back. Fly once, strike once, be replaced by the next airframe off the line. That single change in intent, from a machine designed to survive to a machine designed to be expendable, is where the economics of autonomous war turned. Not in a laboratory, on an assembly line. Over the next decade, that line would produce the most widely used attack drone of its kind anywhere, and it would do it under the most extensive sanctions regime applied to any state this century. The controls were there. The line ran anyway. The weapon that came off that line was not the most sophisticated drone in the world, not the longest range, not the most accurate. It was the most producible. And in a war of attrition, producibility is the only specification that matters. It is a delta wing, a little over 3 meters across, carbon fiber and foam, carrying a warhead of 40 to 50 kilograms. It runs on a small piston engine, reverse engineered from a European design, the low buzz that air defense crews learned to recognize before their radar did. It navigates by satellite, flies low and slow enough to slip under fast interceptors, launches off a truck-mounted rack, and does not return. The family scaled in both directions, a lighter, shorter-range version, and later a jet-powered model that cut the time a defender had to react from minutes to seconds. Every variant was a different answer to the same question: how cheaply can a warhead be delivered to a fixed coordinate, and how expensively will the defender have to respond? That question, asked on a factory floor, reorganized the battlefield more than any breakthrough in a research lab. The strategic value of this weapon is captured in one number, around $35,000. That is the most cited estimate. Others put the true cost lower, closer to a few thousand, others higher, near 80,000 once you count the premium of evading sanctions. The precise figure matters less than the ratio. The guided interceptors fired to shoot these drones down cost between roughly $1 million and $4 million each. So even at the high estimate, the exchange runs more than 100 to 1. At the low estimate, several hundred to 1. Every cheap drone that forces a defender to burn an expensive missile has already won, whether or not it reaches its target. This is the interceptor trap. Defending against cheap autonomous munitions with costly guided interceptors cannot be sustained over any long campaign. The arithmetic does not care how advanced your air defense is. It was set on an assembly line by a decision to make a warhead that costs less than a family car and to make it by the thousand. The capability is not the interesting part. The choice to build it at that price, knowing exactly what it would do, is design this cheap does not stay in one place. Within a decade, the same airframe was being built far from where it started, franchised onto foreign soil, copied by a movement at sea, and manufactured by an armed group that no treaty reaches. On one front, it was produced at an industrial estate at a rate that climbed to roughly 400 a day, with a stated target of 1,000. Investigators found that line was staffed in part through coercion and trafficking, including teenagers and workers recruited from across a continent under false promises. At sea, a movement in Yemen fielded its own copy and used it to attack shipping, helping cut container traffic through one of the world's busiest trade routes by about 90%. Inland, an armed group began building its own variants so that even destroying the supply line could not remove the capability. One design, 3 theaters, No single chain of accountability across any of them. Next Friday, the series turns to China, the one major power building this architecture by deliberate design, and to the calculation that could decide whether this gap becomes the world's default. Lethal by design runs every Friday. The framework meant to prevent all this was not absent. It was documented, debated, and dismantled on a schedule. A Security Council resolution once barred these transfers. Its key restrictions were written to expire on a fixed date. When the date came, they lapsed automatically. The weapons transferred illegally before that date were now legal to sell. Those who had been sanctioned for moving them were quietly delisted. The line kept running. This is the heart of the series argument. The accountability gap is not an absence waiting for better policy. It is an architecture. When investigators dismantled these drones, roughly 4 in 5 of the microchips inside were made in the West, sold through legitimate channels, and routed to the line through front companies in a handful of permissive places. The controls were not missing. They were written, debated, and in one case timed to expire, which they did. For a board, that is the uncomfortable part. A control with a sunset is a control with a deadline. If the only thing between a component you sell and a weapon no one will answer for is a regime that is scheduled to lapse, then end-use governance cannot be left to that regime. Who in your organization actually owns the question of where your technology finally lands? In 2026, every strand of this network met in one war. The weapon built on that assembly line was turned back against the country that built it. An American firm had reverse engineered the same cheap drone at the same price and fired it the other way. In the opening hours, more than 1,000 targets were struck. A smart targeting system built by an American defense software firm and running an artificial intelligence model from a major American company generated hundreds of strike coordinates in those first hours, fusing satellite imagery, drone feeds, and signals data into packages for approval at a speed no earlier targeting cycle had reached. One detail captures the era. The maker of that model had been formally labeled a supply chain risk by the Defense Department one day before the war began. Hours later, the same model was helping choose the targets that opened the campaign. The cheapest precision weapon in history had been universalized, built now by the wealthiest power as well as the poorest, and the machine deciding where it fell was moving faster than any human review behind it. That speed is the next part of the story. The cost of it arrived in the first hour. 1 hour into that war, a precision missile struck an elementary school. The building had its own website, its own social media page, and walls that had separated it from the military site next door for years. 168 people were killed, more than 100 of them children, according to the human rights organization that investigated. The weapon was one used only by one side's forces in that campaign, the investigators found. The intelligence behind the strike was out of date. The targeting system either did not check or was not built to check. The law of armed conflict has a rule for exactly this. Those who plan an attack must do everything feasible to verify that the target is not a school, a home, or a protected place. The rule does not set a minimum time. It says verification must be feasible. When a system generates targets at machine speed, what counts as feasible depends on the databases behind it and on the humans given time. Here, the precaution was feasible. It was not taken. The question of who answers for that was not unanswerable. It was simply unanswered, because no one with authority over the system had been required to answer it. That is the gap made total, not an accident, a choice made by people who could already see it.
That is the Hamberger report for today. If this was useful, subscribe and hit the like button. It helps more professionals find the channel. You will find links to everything we covered in the description below. I am Andreas Hamberger, and I will see you tomorrow.
Like and subscribe.